The 20th century witnessed the rise of heavy industries, shaping the modern world as we know it. Steel, iron, and other metals became the backbone of infrastructure, manufacturing, and technological advancement. This industrial revolution, however, came at a cost, leaving behind a legacy of pollution and environmental degradation. As we progress into the 21st century, the demand for these heavy metals hasn't subsided. In fact, it's only intensified. Emerging economies, with their rapid urbanization and infrastructure development, are driving the demand for metals like never before. This insatiable hunger for heavy metals presents us with a critical juncture. We must find ways to meet the growing demands of our modern world while mitigating the environmental impact of these industries. The future depends on our ability to strike this delicate balance. India, with its burgeoning population and rapidly developing economy, stands as a prime example of this global trend. The construction sector in particular is experiencing an unprecedented surge. New cities are being imagined, and existing ones are undergoing massive expansions. From towering skyscrapers to sprawling residential complexes, the demand for construction materials, especially metals, is skyrocketing. This demand has turned India into a global construction powerhouse, with its appetite for metals shaping the international market. Within this construction frenzy, aluminium has emerged as a metal of choice. Its lightweight, durability, and corrosion resistance make it ideal for a wide range of applications, from window frames and roofing sheets to electrical wiring and even furniture. Globally, aluminium production has been on a steady incline for decades. In 2023 alone, the world produced over 69 million metric tons of aluminium. This figure is projected to increase significantly in the coming years, fueled by demand from industries like construction, automotive, and packaging. India too has witnessed a remarkable surge in its aluminium production. Currently, India ranks among the top 5 aluminium producers globally. This growth is primarily driven by the booming construction sector, which consumes more than half of the aluminium produced in the country. While this growth speaks volumes about India's economic progress, it also raises concerns about the environmental consequences of such large-scale aluminium production. The journey of aluminium from raw material to finished product is a complex and energy-intensive one. It all begins with bauxite, an ore found in abundance in several parts of the world, including India. The first step involves extracting bauxite from the earth, often through open-pit mining. This process requires the removal of vast amounts of topsoil and vegetation, leaving behind a scarred landscape. The extracted bauxite then undergoes a chemical process known as the Bayer process to produce alumina, or aluminium oxide. Finally, alumina is subjected to electrolysis, a process requiring immense amounts of electricity to obtain pure aluminium. This energy-intensive step is often cited as a major contributor to the environmental footprint of aluminium production. Section 5. The unseen costs of production. While the final aluminium product might appear clean and polished, its journey from bauxite to our homes comes at a hidden cost. The production process generates a significant amount of byproducts and pollutants that pose serious threats to the environment and human health. One of the major concerns is the release of greenhouse gases, primarily carbon dioxide, during the electrolysis stage. The reliance on fossil fuels for electricity generation further exacerbates this issue, contributing to climate change. Moreover, the production process also generates a significant amount of wastewater contaminated with heavy metals and other toxic chemicals. If not treated properly, this wastewater can contaminate water sources, harming aquatic life and posing risks to human health. Section 6. Red mud, a crimson tide. Perhaps the most alarming byproduct of aluminium production is red mud, a highly alkaline and toxic residue generated during the Bayer process. For every ton of alumina produced, approximately 1 to 1.5 tons of red mud is generated, posing a significant disposal challenge. Red mud is typically stored in vast holding ponds or landfills. However, these storage facilities are prone to leaks and spills, posing a constant threat to the surrounding environment. The alkaline nature of red mud can contaminate soil and water bodies, making them unsuitable for agriculture and aquatic life. The catastrophic consequences of a red mud spill were tragically demonstrated in 2010 when a dam at an alumina refinery in Hungary collapsed, releasing millions of gallons of toxic sludge into nearby villages, killing 10 people and injuring hundreds. Section 7. The environmental price tag. The environmental impacts of aluminium production extend far beyond greenhouse gas emissions and red mud. The extraction of bauxite through mining leads to deforestation, habitat destruction, and biodiversity loss. The transportation of raw materials and finished products further contributes to air pollution and traffic congestion. Moreover, the disposal of aluminium products at the end of their life cycle poses additional challenges. While aluminium is recyclable, a significant portion still ends up in landfills, where it can take hundreds of years to decompose. Addressing these environmental concerns requires a multi-pronged approach, including investing in cleaner production technologies, promoting recycling and reuse, and finding sustainable alternatives to traditional aluminium production methods. Section 8. Health at stake. The environmental impacts of aluminium production are intricately linked to human health. Exposure to air and water pollution from aluminium plants can lead to respiratory problems, skin diseases, and other health issues, particularly in communities living near these facilities. The consumption of food and water contaminated with heavy metals like mercury and aluminium can have long-term health consequences affecting the nervous system, kidneys, and other vital organs. Children are particularly vulnerable to the toxic effects of heavy metals, which can impair their cognitive development and overall well-being. Ensuring the health and well-being of communities affected by aluminium production requires stringent environmental regulations, proper waste management practices, and access to healthcare facilities equipped to diagnose and treat heavy metal-related illnesses. Section 9. A sustainable future. A choice to make. As we stand at the cusp of an aluminium-driven future, the choices we make today will determine the legacy we leave for generations to come. Will we continue down a path of unchecked industrial growth, prioritizing economic gains over environmental and human health? Or will we choose a more sustainable path, one that balances the need for progress with the imperative to protect our planet? Embracing innovative technologies, such as inert anode technology, which eliminates greenhouse gas emissions during the electrolysis stage, can significantly reduce the carbon footprint of aluminium production. Furthermore, exploring alternative materials with lower environmental impacts can help lessen our dependence on aluminium. Ultimately, the responsibility lies with governments, industries, and individuals to make conscious and informed decisions that prioritize the well-being of both people and the planet. The future of aluminium, and indeed our own, depends on it.